Okay, we are on CBE 4. Okay, this did not show up in the book. This is a rational inequality. So we're going to treat it like a rational expression, and then we're going to have to do something a little strange to find the answer. So basically, we want to know, when does this value come out to be less than or equal to -1? So I factor the denominators. One side is x minus 9, one is x times x minus 9. To put the fractions together, I need a common denominator. What is the common denominator going to be? X times x minus 9. So the left side needs an x over x, and the right side doesn't need anything. Okay? So we get 9x minus 4 is less than or equal to -1 over x times x minus 9. Does that make sense? Okay. Now what should I do? So, so you're saying conjugate? Multiplying by conjugate. So let's say I times this by x minus 9, or sorry, x plus 9, and x plus 9. Okay, and then we would work out inside there what the conjugate would end up being. But then I would have to multiply this by x plus 9 over x plus 9. Would that work? I mean, eventually you could get the answer. I don't think that's the way that we want to go. What if I try to just move this stuff to the other side? So if I times this by x over x minus 9, and then I times this by x over x minus 9, that seems like a really good strategy. But it's dangerous. Why might that be a bad idea? Is x times x minus 9 positive? Maybe, right? And if x times x minus 9 is positive, then I'm not going to have any problems. But what if this is negative? Then I have to flip the inequality, and that's a problem, right? So that's not going to work either. So here's what we're going to do. I chose poorly. Okay. So I want to know where this particular fraction is less than or equal to -1. It's actually easier to find when a fraction is greater than or equal to 0. So I'm going to move this to that side. So we have 9x minus 4 over x times x minus 9 plus 1. Okay. And that has to be less than or equal to 0. Now, because this is an inequality, my answer is going to be made up of intervals. If I were to draw the number line, well, if I were to graph this, then it's going to look something like this. All rational expressions have that sort of shape. Okay? But I don't care where this graph crosses the x-axis as much as I want to know when the graph is greater than 1, when it's less than or equal to -1. So what I want to do is draw a line at -1, and I want to find the pieces of the graph that are below that. Okay, but it's actually easier to compare it to 0 than it is to compare it to -1. So I moved the -1 to the other side, and it became a +1, and now I have an inequality that is less than or equal to 0. So it's a slightly different graph. It's been shifted a little bit. Can you tell me the important points of the x-axis? So in this graph, there are several what we call critical points in calculus for this graph on the x-axis. Where are they? Nine is one of them. What happens at 9? We have so at x equals 9, we have a vertical asymptote. Where else? At 0, we have a vertical asymptote. Is there a 0 at 4/9? If it was 9x minus 4 equals 0, then yes. But that +1 is going to mess things up. So what should I do with that +1? I need to put that in the common denominator. So this needs an x times x minus 9, and this needs an x times x minus 9. So the numerator is now, so that's x squared, the 9x and the negative 9x cancel, minus 4 over x times x minus 9 is less than or equal to 0. So what other points are important? 2 and -2. What happens at 2 and at -2? Those are roots. So the graph crosses the x-axis at -2. It does not exist at 0. It crosses the x-axis at 2, and it does not exist at 9. Does everybody understand that? Now, the second time we do one of these is going to be a lot faster. Okay, so here are the options. The graph either looks like this. Now, how did I know it looked like that? Well, we have to cross at the two roots. We have to approach the vertical asymptotes. And if this side goes down, how do I know that this side goes up? When do asymptotes go in different directions? Vertical asymptotes. When it's a single factor. So if we had x minus 9 squared, then they would either both be up or they would both be down. Or if I had x squared, they would either both be up or they'd both be down. The other option is like this. And that's it. There's no other way to do that. So we need to figure out which is which. How are we going to do it? How do we know if it's the black one or the red one? Well, pick a point. Any point except -2, 0, 2, or 9 will work. What would be a really easy number to plug in? 1. Now, when I plug in 1, what am I looking for? All I care about is it less than or equal to 0? Is it positive or is it negative? I don't care how big it is. Is it positive or is it negative? So we put 1 in here. If I put 1 on top, do I get a positive number or a negative number? Negative. If I put 1 on bottom, do I get a positive number or a negative number? Negative. And a negative divided by negative is a positive. So at 1, I get positive, which is this. So I now know it's the black graph. knowing it's the black graph, what intervals will satisfy this equation? I want to know, where is the black graph less than or equal to 0? So it will be this chunk here and this chunk here. What are the x values for those two intervals? So it wants us to use interval notation. Okay? So this will be -2 to 0. Does -2 get a bracket or a parenthesis? Bracket, because 2 is included because this is an equal to. So from -2, when does that piece stop? 0. Does 0 get a bracket or a parenthesis? Parenthesis, because it's a vertical asymptote. We can't reach it. And we union that with 2 with a bracket to 9 with the parenthesis, like that. All right, let me plug that in and make sure I didn't make a mistake. All right, so no. All right, we want this one with a -2, comma 0. Go outside, union that with this one from 2 to 9. All right. Oh, good point. Thank you. We want to do practice. All right, let's try that one again. Okay. So, I want a common denominator for everything. This one needs an x plus 5. This one needs x plus 1 and x plus 5. And this one needs an x plus 1. And then when it's done, I need to move it to the other side, so I have a 0. Okay? Does it matter which side you move it to? No. It just will be above the x-axis or below the x-axis. So, left side is 2x plus 10 plus x squared plus 6x plus 5. And then I'm going to subtract 12x plus 12. And all of that, oh, minus 12, thank you. All of that is over x plus 1 times x plus 5. And this is less than or equal to 0. Simplify. The numerator becomes x squared, 2 and 6 make 8, minus 12 is -4, x, 10 and 5 is 15, minus 12 is 3. So where are my critical points? Well, I have a VA at -1 and -5. Everybody follow? And then I have roots. This would be x minus 3 and x plus 1. So I have roots at -1. Yes. Roots at 3 1 and 3. Okay, so what could this graph look like? Ooh, that's tricky. So it could look like this. Nope. Can't do that. What's it going to do instead? It's going to loop down and miss the x-axis. So it either looks like that or the opposite. Now, what if you're not good at that? What if you can't figure that out? Just plug a point in every section. So plug a point in here, and that will tell you if it's above or below. Plug a point in here, and that will tell you if it's above or below. And then a point here, and a point here, and a point here. So if you can't figure out the shape of the graph, just keep plugging in points until you've tried them all. Okay. Now, when I plug in points, all I care about is positive or negative. I don't care about anything else. Nope. Let's do x squared plus 6x plus 5. Okay, what's going to be the easiest number to plug in? 0. 0 is not one of the critical points, so I'm going to plug in 0, which rests right here. Plugging in 0 is easy. You just cross off all the x's, and I get a positive number, which tells me it's the red graph. Okay, and I want to know, when is the red graph below, equal to, or below the x-axis? So it's this section and this section here. So from -5 to -1, union that with 1 to 3, and both of those get brackets. Okay, if you don't get that, it's okay. Plug in 4, and that will tell you above or below. Then plug in 2, and that will tell you above or below. And then we did 0, and then -2, and then -6. And only keep the ones where we, in this case, we get less than or equal to 0. Okay? All right. So we have the equation y equals a times x plus b plus c. And we want to figure out what the equation is here. Well, how much is this dropping every day? So how did we get from day 0 to day 1? We cut it by half. So we know that this is 1/2. Positive 1/2. So y equals 1/2. Okay. And then x plus b plus c. We also know what c is. Where does the graph cross the y-axis? At 6. So this is 6. Okay. How do we find b? Just plug in that other point right here. So 3 equals 1/2 raised to the 1 plus b plus 6. Let's subtract 6. So -3 equals 1/2 1 plus b. Oh, that's going to cause a problem. when I do the ln of negative 3 doesn't exist. What'd you say, Jace? This is not the way that I would do it, but this is the way that a lot of kids prefer to do it. So can we just drop the negative? Let's just drop the negative and see what happens. So we ln both sides, and I get ln of 3 equals 1 plus b times the ln of 0.5. So we divide by the ln of 0.5, and I get ln 3 over ln 0.5. So ln 3 divided by the ln of 0.5. That is not a nice number. Nope, didn't work. All right, that doesn't work in this case. Sorry. Unless did I make a mistake somewhere? Did I plug it in wrong? So 3, 6, 1, 3. No, I did it right. Okay, we'll do it the other way. Let's pretend that this is my graph right here. What is the equation of that graph? Well, if this is my x-axis, then this would be 1, 2. Did I go up 2? Yeah, 2, 3, 4. So what is the exponential equation that drops by? We're going from 4 to 1. What would that be? It would be y equals 1/4 raised to the, it would be y equals 6 times 1/4 to the x. Is that right? Not 6, it'd be 4. Sorry, it was a 6. Okay. So how do we shift it so that now it looks like that? You're going to add 2 to lift the graph up. Okay, but that's not the form it wants it in. Right? It doesn't want to have a leading coefficient. So if I put a 4 inside there, what is that going to do to the exponent? So every time I go forward one day, I divide by 4. Right? So if I put a 4 in the equation, what is that going to do? Well, what's the exponent right here? It's a 1. So what is 4 to the first times 1/4 to the x? Well, I need to turn this into a 1/4. So 1/4 to the negative 1. Now they have the same base. So it would be x minus 1. Do these have explanations when you do them? No? Okay, so that's the way I would do it, but a lot of students have trouble figuring that out. So let's, I know what I did wrong the first time. Okay, so let's try to do it the other way. So I was wrong when I said it drops by half, because it didn't actually drop by half. We have to treat that as part of the drop. How far does that drop? 1/4 of, you end up with 1/4 of the total distance. Okay, that's why it didn't work. So this is a horizontal asymptote. If I start here at 6 and a day later I end up at 3, how close am I to the horizontal asymptote? I dropped 3/4 of the distance. So my new number is 1/4 as big, because the total distance is 1, 2, 3, 4, and I dropped 1, 2, 3 of those. That's why it didn't work. That's why I got a negative. So y equals 1/4 times x to the x plus 2. Or, sorry, plus x plus b plus 2. There we go. Boy, I was all sorts of off the scale. y2. So the number in front of the 1/4 is the y-intercept. With exponential equations, the plus is not the y-intercept. The plus tells you where the horizontal asymptote moved to. So this graph, the horizontal asymptote started at 0 and it went up 2. Now we can plug in 1, 3. So we plug in 3 here, we plug in 1 there. Subtract 2, and I get 1 equals 1/4 1 plus b. ln both sides. So the ln of 1 is equal to 1 plus b ln of 1/4. Divide by the ln of 1/4. And ln of 1 over ln to the 1/4 is 0. Right? What number, what exponent can you put on 1/4 to get 1? 0. So we get 0 equals 1 plus b, and we subtract 1 and we get b equals 0, or negative 1. Okay, let's do a couple of these. And again, these look tough, but they're actually not too bad, as long as I do them the right way. Okay. Number 2. All right. So this one's upside down. What does that do to this equation? It makes a negative. So I know the equation is y equals negative a x plus b plus c. Okay? So my horizontal asymptote has changed. How has it changed? The horizontal asymptote is always 0 in exponential equations until it's been shifted. So it has gone up 1, 2. So this is going to be plus 2. Okay, now for the hard part. In reference to this line, what happened from here to here? I started with a distance of 2, and a day later, I now have a distance of 1. And how do you go from a distance of 2 to a distance of 1? You times it by 1/2. Because it's upside down, it's negative 1/2. So y equals negative 1/2 x plus b plus 2. Now, make sure you put the negative in parentheses. It's not the opposite of 1/2 raised to the x plus. Actually, it is. I lied. Make sure you don't put the negative in parentheses. What? 0, 0, and 1, 1. Why does the negative have to go outside? Well, you can't ln a negative. Yeah, that's going to be a problem. Good. That's a good way to put it. But negatives on the outside flip graphs upside down. If you put it on the inside, then you are essentially squaring a negative or taking a cube of a negative, and sometimes that's positive and sometimes that's negative. So always leave the negative outside. Now what should I do? Plug in 1, 1. So I put a 1 here and I put a 1 there. So 1 equals negative 1/2 x plus b plus 2. What should I do? Subtract 2, and I get negative 1 equals negative 1/2 x plus b. Now what? Oh, x is supposed to be 1. 1 plus b. What should I do? I need to multiply or divide by negative 1. Basically, flip the signs. Now I can ln and drop that. And I get the ln of 1 over the ln of 1/2 equals 1 plus b. But what is the ln of 1 over any ln? 0. So the ln of 1 divided by the ln of 1/2 is just 0. Because what exponent can you put on 1/2 to create a 1? 0. So 0 equals 1 plus b. Subtract the 1. And now I know that this is x minus 1. Okay, now they both ended up being negative 1. That's not going to happen every time. So let me do one more. I really wish... If I do check answer, will it give me another problem? No? All right, give me a better one. Okay. Oh. All right. So, what can you tell me about this graph? It's negative because it's upside down. Okay, what else? The c is plus 2. So the final equation is y equals some negative number, x plus or minus some number plus 2. Okay, now compare these points to the horizontal asymptote. How far away is this point from the horizontal asymptote? 3. How far away is this from the horizontal asymptote? 1. How do we get from a 3 to a 1? 1/3. And because it's upside down, it's negative 1/3. Everybody understand that? Okay. So now I need to plug in the 0.11. So 1 equals negative 1/3 1 plus b plus 2. Oh, subtract 2, and this becomes negative 1. Flip the signs. ln both sides, and we get ln 1 over ln 1/3 equals 1 plus b. And once again, the number is negative 1. I don't think that's going to be the case every time. So this would just be a negative 1. It would be nice if they were. Okay, do you need to see another one? Think you're good? Okay. Number 3. All right, this looks really hard, but you should get these done pretty quickly. They shouldn't take you much time at all. So, simplify the logarithmic expression. I need to put this 3 up there. What does a third power and a third root do? They cancel. So a third root and a third power cancel. That's handy. Okay. They're all log base b, right? So we can squish them together. So we're going to have a single log base b, and everything that is positive lands on top, and everything that is negative lands on bottom. So b to the 5th over k to the 5th times this one. So b to the 5th, k to the 5th times k to the 9th, b to the 5th over k to the 4th, b to the 10th. Does everybody follow? And then we just simplify. K to the 5th turns this into a 4th. And now this fraction is gone. B to the 5th and B to the 5th cancel the B to the 10th. And the K to the 4th cancels this K to the 4th. So I get log base B of 1. And B to what power is 1? 0. So this thing is just 0. Okay, let's do another one. Now they're all going to simplify to something pretty easy, but it's not going to be 0 every time. Three, I think. All right. So this 3 is going to cancel that 3. Log base A, j to the 5th, a to the 9th times j to the 3rd over a over j to the 8th, a to the 4th. So this a turns that into an 8. And this 4 turns that into a 4. And these 8 j's cancel that j. So we get log base a of a to the 4th. But what can I do with that 4? Bring it out front. And then what is log base a of a? It's just 1. So the answer is 4. Okay, they'll all do something like that. If you get a big messy equation, you made a mistake. Can you handle another one today, or do you want to work on those 3? One more? Oh. How do we do that? ln 236 over the ln of 4. All right. This looks tough, but it's not. So log base b of 4 equals that number, and log base b of 8 equals that number. So we want log base b of 1 over 32. So we need to build this fraction using only 4s and 8s. How can we build 1 over 32 using only 4s and 8s? So log base b of what? 4 times 8 is 32. Does that make sense? Well, no, not quite yet. That's the hard part. So how do we build 32? We take 1 over 4 and we times it by 1 over 8. Okay? Now, let's split this into 3 logarithms. What would they be? Log base b of 1 minus log base b of 4 minus log base b of 8. But what is log base b of 1? It's just 0. So I don't need that one. Okay. Do I know what log base b of 4 and log base b of 8 are? Yeah, it gave me the decimals. So I don't know what b is, but I can figure it out by just taking the opposite of this and subtracting that. Okay. What if it said log base b of 2? How do I build a 2 using only 8s and 4s? So we're going to do log base b of 8 over 4. Now I split that. So log base b of 8 minus log base b of 4. And so the answer is just going to be 3.322 subtract 2.215. Do you want to see any more of those? Okay, that's 1 through 5. We're halfway. Okay, get to work.